Hey guys, this is Mrs. James.
And Mr. Jackson.
We're here to go over the stem and leaf plot homework assignment. So let's get started.
Okay, question number 1. What is the name of the data organizer used to display the fast food statistics? And the name of our data is going to be the stem and leaf plot. Question 2. What is the stem and leaf plot used? Or why is the stem and leaf plot used? The stem and leaf plot helps us look at large lists of numbers to see how the numbers are grouped. They also help us look at where there are clusters of numbers. Question 3. How do you know how to read the stem and leaf plot? And as you can see, we have the key highlighted for you in our chart. The key is at the bottom of the stem and leaf plot. And each stem and leaf plot must have a key describing how to read the data. Question 4. What does the data in the stem and leaf plot represent? And at the very top of our stem and leaf plot, we have the name of our data is going to be the fat grams and fast food items. It tells you in the title what we're looking for. Question 5. How many items are listed on this chart? There's 32 items.
And guys, you can go ahead and pause it whenever you need to. I know we're going a bit fast. Go ahead and count with yourself how many items and see if you got what we got. On number 6. Guys, just remember also that you need to only count the leaves when you are counting how many total items you have on this chart, and the leaves are the ones that are on the right-hand side. The stem, think of it like a tree. The leaves are on the outside, and the stems are what is on the left side connecting to the leaves, if that makes sense. But anywho, just make sure you count the leaves when they're asking how many items are listed. Number 6, what is the largest number of fat grams? That is 107, as you can see here. And guys, how we write that is, we kind of wrote an example here. The 10 is on this left side, and the 7's over here. So that equals 107. Number 7, what is the smallest number of fat grams? So you need to look back at the top of your chart and see that the smallest number is 9 grams. And you can see here how we wrote that. It has a 0 right there. That just means that there's nothing in the first place value. Number 8, where does this data cluster? So we kind of already drew where it clusters here. But let me show you what to write for these few. So as you can see from the chart, the data clusters between 9 and 40. And what we mean by cluster is, let's just look up here. That's where a lot of the data points are mostly centered, right here. So number 9, are there any values that do not cluster? How many values do not cluster? Again, you're going to look at your chart and see that yes, there are 3 values that do not cluster. And those values are numbers 61, 86, and 107. Those are not in the clusters. All right, and number 10, the values that do not cluster are called outliers. Why do you think they are called outliers? That's a good question to think about. They lie outside, they lie on the line, and they are not grouped with the rest of the data, so they're not clustered. And that's why they're called outliers. They lie on the outside. Alright guys, I hope you enjoyed our video. Welcome back from spring break. Y'all are doing great. We'll see you in class.